This is Unit 8, video number 1. Random samples and surveys. Statistics deals with collecting, organizing, and interpreting data. A survey is a method of collecting information. The group being surveyed is the population. Sometimes the population is very large. To save time and money, part of the group, called a sample, is surveyed. To get valid results, a sample must be chosen very carefully. An unbiased sample is selected so that it accurately represents the entire population. 2 ways to pick an unbiased sample are listed below. The first way is called a simple random sample. A simple random sample is described as follows. Each item or person in the population is as equally to be chosen as another. An example of this might be that each student's name is written on a piece of paper. The names are placed in a bowl. And picked without looking. The second unbiased sample is a systematic random sample. Systematic random sample is described as the items or people are selected according to a specific time or item interval. For example, every 20th person is chosen from an alphabetical list of all students at the school. In a biased sample, one or more parts of the population are favored over others. 2 ways to pick a biased sample are listed below. The first type of biased sample is called a convenience sample. Convenience sample is described as consisting of members of a population that are easily accessible. For example, to represent all the students attending a school, the principal surveys the students in one math class. The second type of bias samples is called a voluntary response sample. A voluntary response sample is described as a sample involving only those who want to participate in the sampling. So, for example, students at a school who wish to express their opinions complete an online survey. Please turn the page. Let's look at the examples together. Example number 1. Every 10th person who walks into a department store is surveyed to determine his or her music preference. Out of 150 customers, 70 stated that they prefer rock music. The manager concludes that about half of all customers prefer rock music. Is this conclusion valid? Justify your answer. So the first thing we want to do is determine whether this is biased or unbiased. Since the person doing the survey asked every 10th person walking into the department store, this is considered a systematic random sample, which is in fact valid. Example number 2. A radio station asks its listeners to indicate their preference for one or two candidates in an upcoming election. 72% of the listeners who responded preferred candidate A, so the radio station announced that candidate A would win the election. Is the conclusion valid? Justify your answer. So the key here is the listeners who responded. This is considered a voluntary response sample. Because only the people who wanted to respond did. So it's an invalid result. Example number 3. The data from 2 random samples of 100 students regarding their lunch preferences are given below. About how many servings of pizza should we order to serve lunch to 1,200 students? So the first thing that we want to do is combine the results of these 2 surveys. So out of the student survey, 24 said they want burgers, 25 said they want tacos, and 151 said they want pizza, out of a total of 200 people surveyed. Since this is a random sample, it's valid. We can use a proportion to figure out how many we should expect given a larger population. So we can compare pizza to the total number of students. First, in our survey, 151 students out of 200 surveyed said they would prefer pizza. We want to know how many would prefer pizza out of the entire population of 1,200. Now we cross multiply, so 151 times 1,200 is equal to 200 times x. 151 times 1,200 is 181,200. Lastly, undo multiplication with division. So we can expect 906 students to want pizza. Example number 4. The data in the table below is from a random sample of 5,000 registered voters to predict the outcome of the election. What percentage of the voters support candidate B? So candidate B has 2,074 voters out of the total population of 5,000 people surveyed. We want to know the percent, and percent is always out of 100. We can cross multiply. 2,074 times 100 is equal to 5,000 times x. 2,074 times 100 equals 5,000x. Undo multiplication with division. And we get 41.48 equals x. So about 41.48% expect candidate B to win.